Okay, simplify expressions via index laws. So, got all our index laws here. If you don't remember where most of these come from, maybe go back to the linear 002 on the YouTube page. But I'm assuming at least some familiarity with all of that. So we've got all our basic index laws. These guys are shorthands as well that come from those. One thing to keep in mind is 0 to the power of 0 is undefined. That shouldn't come up too often, but every once in a while people like to make it equal either 1 or 0, depending on which of these two they're trying to follow. And it's neither, because it's contradictory, so it depends. So we get undefined for that. So we're going to jump in and do some annoying things. So we've got all of this stuff. Alright, well, I've got all of this to a power of 5. Great. Whenever I've got stuff to a power, I should just multiply out the powers, keeping in mind that's a 2 to the power of 1, effectively. So we've got 2 to the 5. You could change this into a 32 if you wanted to. I'm going to suggest that you don't turn things into bigger numbers, because bigger numbers typically make things more annoying. We'll deal with it later. So we've got a to the 15, ooh, that's a 15, b to the negative 20. I'm not worried about having negative powers because we're not afraid of that. 2 to the 3 to the 4, so I get 2 to the 12, a to the negative 8, and that's b to the 1, so b to the 4. All over. Can't simplify anything on the bottom. 3 by a to the 2 by b to the 4. Now, some people like to cross straight away, and that's fine, you can do that. I suggest that you try to simplify the top as much as you can, and then try to simplify the bottom as much as you can, and only then cross-contaminate them afterwards. Okay, well, what else have we got? We'll take a look at the top. I've got a whole bunch of 2s, so 2 to the 17, a to the, what's that, 7, b to the negative 16, all over, so equals, a to the 2, b to the 4, last bit, okay, I've got 2 on top, no other 2s, so he's stuck. So whatever 2 to the 17 is, some terribly huge number. A to the 7 over a to the 2, so I've got a to the 5, b to the negative 16 over b to the 4. So I could make this b to the negative 20, but since it's going to be negative, I'm going to put it on the bottom, b to the 20. And I've still got this 3 chilling out on the bottom. Brilliant. 2s, A's, 3's, B's, nothing else is repeating. I'm done. That's as simple as that'll get. You could figure out whatever 2 to the power of 17 is. That's going to be a monstrous number, so I'm going to elect not to do that in this particular case. If it's something like 2 to the 3, then typically you'd change it into an 8. But if it's something stupid like that, we don't have to. Cool, so that's pretty straightforward. That should be pretty old hat at this point. Some more algebra within algebra. Okie dokie. Same rules as before. If you can simplify the top any further, do that. If you can simplify the bottom any further, do that. Okay, I've got 2s, 3s, A's, nothing's in common there, okay? 4s, 6s, A's, at first glance you might say, well, there's nothing in common there, but I would have you think, hang on, 4s are just 2 to the power of 2, 6 is 3 times 2. So I've actually got 2s and 3s in here, and I've got 2s in there. So, what I'm going to do, 2 to the n plus 1, by 3 to the 2n minus 1 by an, so nothing's changed on top. This I'm going to change to 2 to the power of, now that would be 2 to the 2, and then that 2 is going to multiply, so 4. This is going to be 2 to the power of 3n plus 2, multiplied 3 to the power of 3n plus 2, multiplied by a to the 2n minus 1. Cool, alright, we've got a whole lot of 2's together now, so we can go 2 to the n plus 1, the top's not changing still. You could do multiple steps in one shot, but that's usually how you make errors, so let's not do that just yet. 7n plus 2, 3 to the 3n plus 2, oops, minus 1, beautiful, okay. Come on, new line. Okay, great. That's everything in terms of 2s, 3s and A's, and obviously 2s can't go to 3s or to A's. Brilliant, so now we can start crossing down this minus this, so I've got 2 to the negative 6n, 1 minus 2 minus 1, times 3 to the 2n minus n is negative n. Negative 1 minus 2 gives me negative 3, multiplied by a to the n minus 2n, so n, so negative n I should have said, minus negative 1 becomes plus 1. At this point you could potentially leave it there. Alternately you could switch it around so that none of these are negative powers. You've got options. So, did I change it? Yes, I did. Cool. Alright, so we've got all this. All of this is negative, so I could put that whole thing on the bottom. All of this is negative, so I could put that whole thing on the bottom. This is only partially negative, so I could do one of two things. I could put a 1 on top and just put this down the bottom. Notice that that's going to switch. Or, if I didn't like this, if I wanted the a on top for whatever reason, I could say a to the 1 minus n, because all I've done is change the order of that, kept it on top. 2 to the 6n plus 1, 3 to the n plus 3. So at this point we've got multiple different options. So this is fine, or this is also fine. Sometimes you'll have to go in the back of the book and the version that you've got won't exactly match theirs. That doesn't mean necessarily that it's wrong, it just might be another equivalent version, so just be careful about it. Most of the time there's a more obvious one, so case in point, like this is technically still correct, it's just not fully simplified. These are both fully simplified. Even that one you could argue was fully simplified, but it's considered by convention to be basically rude if you've got negative powers everywhere. So you're typically trying to get rid of as many negatives as possible in the powers. Okay, great. What about this thing? Alright, well now we've got fractional powers. So, well, square root, there's no number there, so it's implied square root. So that means that this is to the power of a half. So just to make that abundantly clear, we've got a to the 3, b to the 4, all of that to the half. And here we've got 8ab squared, all of that. Cubic root is power of a third. Cool. Alright. Well, we can distribute that through. So I've got a to the 3 on 2 by b to the 2 over. Now, 8 to the power of 1/3. Well, hang on, that's cubic root. Something multiplied by itself 3 times gives 8. That would be 2, so we can change that perfectly into a 2. Cool. A to the 3rd, b to the 2/3. Okie dokie. Cancelling things down, I'm going to have the 2 on the bottom no matter what I do. And that's going to be there, yep. A and 3 halves minus 1/3, so now I'm going to have to talk about sixths. Okay. So this is 9 sixths and 2 sixths, so that gives me 7 sixths overall. B to the 2 minus, so 2 minus 2/3 gives me 4/3. Yes, yes. Cool. So that's perfectly fine. Another way that you could write it though is to say I'm going to have a half out the front, so that's the 2, multiplied by the 6th root of a to the 7 multiplied by the 3rd root of b to the 4. So both of those perfectly valid. Either way, common rather is to switch out fractional powers for roots. It's not strictly required though. So just again, the answers in the back of the book could be in either form. So you just got to be able to switch back and forth. Last one. Okay, this one looks a bit more fiddly because it doesn't look like anything is in common immediately. But we're told that we have to simplify it, so we should probably look at it and go, alright, well, I can't do anything to the top. How about this? Well, if I notice, I've got a square root, and then I've got this thing which I can factorise slightly. So I could say that's 4 with 3x plus 2, and now that's looking super suspicious, because I've got the same thing twice. Ooh, and that blue's starting to run a bit thin. That's a bit better. I've just hit a dead spot. Okay, well, I can take out this square root of 4, so I can make this 3x on 2 on top, over square root of 4 is 2, multiplied by square root of, actually I don't even need that, I'll just make it square root of. This is all divided, there we go. 3x plus 2. Okay, Well, I've got all of this thing to the power of a half, so I can think of this as this whole thing to the power of 1 divided by 2 to the same thing to the power of a half. Okay, this thing to the half divided by this thing, this thing to the 1 divided by this thing to the half. 1 minus a half would be a half still. So I've got 3x plus 2 to the half all over 2. Or alternately, we could write that as, so that's the 2 coming out the front, root 3x plus 2. So again, either of those are potentially valid. Obviously this one looks a lot neater though, so that's most of the time the way that you're going to see it. Cool, so that's that. For the most part, this is just about running your rules, just killing off as many things as possible, and not making any dum-dums along the way. Again, highly recommend clear the top, clear the bottom, then cross-contaminate. When in doubt with things like this, separate them all out into their prime factors. So for 4, obviously that's 2 and 2. For 6, that'd be 2 and 3. If you had 15, it'd be 3 and 5. So you're splitting it up into its primes. Cool. That's everything. Should be, for the most part, old stuff, just with a little bit more annoyances in the way, but generally still the same. If you get stuck on anything, email me. Otherwise, cheerio.